Antarctica, the southernmost continent, holds the majority of Earth's ice and a significant portion of its freshwater reserves, covering about 14 million square kilometers, 5.4 million square miles. It is home to an estimated 25,400,000 cubic kilometers, 6,090,000 cubic miles of ice. This immense ice mass accounts for roughly 60% of the planet's freshwater and 90% of all its ice. The implications of this ice melting entirely are profound and far-reaching, affecting global sea levels, climate patterns, ecosystems, and human societies. Sea level changes and geographic impact. If all Antarctic ice melted, it would result in a dramatic rise in global sea levels by approximately 70 meters, 230 feet. This rise would drastically alter the world's coastlines, submerging entire regions and reshaping the geography as we know it. Submerged cities and lost land coastal cities across the globe, including major metropolises like New York, Tokyo, and London, would be completely submerged. The state of Florida would vanish entirely beneath the rising waters, and low-lying countries such as the Netherlands, Bangladesh, and Denmark would lose significant portions of their land. Island nations would be especially vulnerable, facing complete inundation and disappearance. In regions like Australia, the rising sea levels would create a large inland sea, fundamentally transforming the landscape. River estuaries would expand significantly, and the paths of rivers would change as floodplains and riverbanks become submerged. This expansion would create new waterways and affect existing aquatic ecosystems. Population displacement. An estimated 40% of the world's population lives within 100 kilometers, 62 miles, of a coastline. The inundation of coastal areas would force billions of people to relocate to higher ground, creating unprecedented levels of displacement and posing significant challenges for urban planning, infrastructure, and resource management. Changes in ocean chemistry. The melting of Antarctic ice, which primarily consists of fresh water, would significantly alter ocean chemistry. This influx of fresh water would decrease the salinity of the oceans and affect various dissolved chemicals and the pH levels of seawater. Impact on salinity and marine life. A reduction in ocean salinity would have complex effects on marine ecosystems. Some marine organisms, particularly those sensitive to changes in salinity, might struggle to adapt, leading to shifts in species distributions and potentially disrupting food webs. Coral reefs, which rely on specific salinity ranges, could be particularly affected, exacerbating the challenges already posed by ocean acidification and rising temperatures. Effects on oceanic currents and climate. Oceanic currents, driven by gradients in temperature and salinity, play a crucial role in regulating global climate patterns. The influx of fresh water from melting ice would disrupt these currents, potentially altering climate systems such as the Gulf Stream and the thermohaline circulation. Such changes could lead to regional climate shifts, affecting weather patterns, precipitation, and even the distribution of heat across the planet. Isostatic rebound and geological effects. The melting of Antarctic ice would trigger a process known as isostatic rebound, where the Earth's crust, previously compressed by the weight of the ice, begins to rise. The mechanics of isostatic rebound. Antarctica, currently weighed down by its ice mass, would experience uplift similar to a heavily laden ship rising in the water when cargo is removed. This uplift would occur over tens of thousands of years, with an estimated initial rise of about 7.5 centimeters per year for the first 2,000 years, gradually decreasing to about 1 centimeter per year over the subsequent 10,000 years. The total uplift could reach up to 400 meters in some areas. Long-term geological changes. This isostatic rebound would lead to significant geological changes, including the formation of new landforms and the alteration of existing topography. The uplifted land would eventually stabilize, but the process would be accompanied by increased seismic and volcanic activity as the Earth's crust adjusts to the new equilibrium. Temperature effects and habitability. The complete melting of Antarctic ice implies extreme global warming scenarios, with temperatures rising far beyond current projections. Under such conditions, the tropics would become uninhabitable due to extreme heat, forcing populations to migrate toward the poles in search of more temperate climates. This shift would disrupt agriculture and food production, leading to widespread crop failures and threatening food security. Ecosystem collapse and mass extinction. Ecosystems across the globe would face collapse as rising temperatures and altered precipitation patterns create inhospitable conditions for many species. This would likely result in a mass extinction event, with significant losses in biodiversity and the disruption of ecological networks that support human life. Historical context. The last ice-free Antarctica. The Antarctic ice sheet began to form around 35 million years ago, during a period when global temperatures were about 4 degrees Celsius higher than today. Before this ice formation, Antarctica experienced different climatic conditions and ecosystems. The isolation of Antarctica over the South Pole and the development of the circumpolar current, resulting from the drift of South America away from Antarctica, contributed to the continent's cooling and the formation of the ice sheet. This current prevented warm water from reaching Antarctica, allowing the ice to accumulate. During the late Cretaceous period, approximately 90 million years ago, Antarctica was covered with temperate rainforests, similar to those found in present-day New Zealand. These forests thrived in a warmer climate, with high levels of carbon dioxide, 1,120,680 ppm, and long periods of darkness during the polar night. The transformation from a temperate, forested continent to an icy wilderness highlights the dynamic nature of Earth's climate and geological processes. Potential large-scale melting events. Current scientific observations and models suggest that parts of Antarctica, particularly the Thwaites Glacier and the West Antarctic Ice Sheet, WAIS, are vulnerable to significant melting. The Thwaites Glacier, located in West Antarctica, is a critical area of concern due to its potential to collapse in the coming decades. If this glacier were to melt completely, it could contribute around 65 centimeters 2 feet to global sea levels. This possibility underscores the importance of monitoring the glacier to understand the mechanisms of ice sheet collapse and to prepare for potential sea level rise. The WAIS, which includes the Thwaites Glacier, could also collapse over a longer time frame, potentially raising sea levels by about 4 meters, 13 feet. The stability of the WAIS remains uncertain, with predictions suggesting that significant changes may not become clear until 2100 or later. The likelihood of complete Antarctic ice melting. Despite the alarming potential consequences, the complete melting of all Antarctic ice remains highly unlikely within the next several hundred years. Even under extreme climate scenarios, it would take a prolonged period of sustained warming to melt the entire ice sheet. Current climate models project significant ice loss in Antarctica due to rising temperatures, but they do not predict total melting. Mitigation efforts, including reducing greenhouse gas emissions and enhancing climate resilience, are crucial in preventing the worst-case scenarios of ice melt and associated sea level rise. Addressing the challenges posed by Antarctic ice melt requires long-term strategies focused on sustainable development, environmental conservation, and global cooperation. By understanding the complex interactions between ice sheets, climate, and human activities, we can develop effective policies to mitigate the impacts of climate change and preserve our planet's future. The hypothetical scenario of all Antarctic ice melting presents a stark reminder of the interconnectedness of Earth's systems and the profound impact of climate change. While the complete melting of Antarctica is unlikely in the near future, the potential consequences underscore the importance of proactive measures to address climate change and protect vulnerable ecosystems and communities. As we continue to study Antarctica's ice dynamics and monitor changes in the region, it is essential to integrate scientific knowledge into policy decisions and public awareness. By doing so, we can build resilience against the challenges posed by a warming world and ensure a sustainable future for generations to come. If all the ice in Antarctica were to melt, the environmental consequences would be severe and widespread globally. First, the global sea level would rise by approximately 70 meters, 230 feet, leading to the flooding of numerous coastal cities, erasing many low-lying nations, and displacing billions of people. The chemical composition of the sea would also become a concern, as fresh water from the melting ice would reduce ocean salinity, impacting marine ecosystems and potentially disrupting critical ocean currents that influence climate. Additionally, the disappearance of the ice would trigger isostatic rebound, causing the Antarctic continent to rise due to the loss of ice weight, a process lasting tens of thousands of years and potentially leading to significant geological changes. The temperature effects from the ice melt indicate that global temperatures have risen significantly, surpassing extreme climate change scenarios, making many tropical regions uninhabitable and causing ecological disasters such as crop failures and mass extinctions of various plant and animal species. This scenario underscores the importance of mitigating climate change, protecting sensitive ecosystems, and enhancing adaptation measures to safeguard humanity and biodiversity from potential consequences. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.